I know that you're a strong advocate for reproducibility. Could you speak around your experiences in this area and some of the issues and debates in the field as well?
Absolutely. Well, this is very much my sort of bread and butter. So when I did my PhD X years ago, I won't give the numerical value of X, but it was all on P values. And so I called my thesis To P or Not to P, because I know there is still currently an ongoing debate in, shall we say, the literature about the appropriateness of P values. And indeed, there's been examples of some journals sort of effectively banning the use of P values. Now, my view is there's nothing wrong with P values. The problem is people don't fully understand what they are. And this is usually due to perhaps, shall we say, poor instruction or just a lack of understanding or miscommunication about what p-values do tell us versus what they do not tell us. They do not give cast iron guarantees. If you have a statistically significant result, doesn't mean that is a discovery. A significant result is a positive result, but any positive is either going to be a true positive or a false positive, just as any insignificant result. It's a negative result, and it's either a true negative or a false negative. And especially in my teaching, I often try to link this to the various COVID tests. So I'm sure everyone listening has taken many COVID tests over the years, for which it's not a statistical test, but nonetheless, it is a test. And if we ignore the inconclusive results, your test, whether it's your PCR, rapid antigen, or anything else, is going to return either a positive or negative result. But a positive result does not mean an individual has COVID. It means the test thinks the individual has COVID. And none of these tests are perfect. Just as a negative result does not mean the person is sort of a virus-free. It could be that they are asymptomatic and the test failed to detect it. So especially in these sort of medical diagnostic tests, the issues of sensitivity and specificity, and this lends themselves very nicely to these ideas of false positives, false negatives, which I'm very passionate about and feel this needs to be fully explored in the appropriate online module for this course, such that whenever people are doing statistical testing, they have a sense that this is not cast iron truth. A type 1 error, type 2 error, false positive, false negative, respectively, could always occur. And hence an emphasis on the need for reproducibility of results. If you've made a genuine discovery, if it is a true positive rather than just a positive, which could be a false positive, then you should be able to replicate those results again and again and again with new data sets when one is testing and retesting. Likewise, insignificant results. I'm sure there are countless examples in human history, we just don't know what they are, of these sort of missed discoveries. People got a large p-value and they thought there's nothing here, and that could have been simply a false negative, and perhaps there was no further exploration of that route, and there's probably countless of missed discoveries to date. So yeah, a strong emphasis on reproducibility, but also distinguishing between statistical significance and practical significance, because some people are, I think, or many people are trained to just look at this p-value and this is almost sort of truth about the world. Well, it is not, but also what things or what factors affect the magnitude of a p-value. So looking at things like the effect size, the influence of sample size, and especially a key danger, I think, in a world of big data. There's various definitions of what big data is, but if we focus purely on, shall we say, the quantity of data, if your sample size is large enough, almost everything becomes statistically significant, but in such cases, very often the result is of zero practical significance. So it's about sort of deep diving into these areas. So it's not just your sort of bog standard hypothesis testing module, but having a deeper appreciation of false positives, false negatives, statistical power of tests, such that people are clear in their minds about what a specific p-value is telling us, and so that there's no sort of misleading conclusions are drawn due to an incorrect understanding and appreciation of what p-values truly are.